Hello, everyone, and welcome to our second webinar in the CG webinar series. Today, we'll have Dr. Margaret Blackie, she prefers Mags, and Dr. Ashish Agrawal. They're both professors. Mags is an associate professor at Rhodes University, and Ashish is an assistant professor at Rochester Institute of Technology. Just a bit of housekeeping before we begin. This seminar is being recorded on Zoom, and you will be able to have access to not just this one, but all the webinars in this series. We had one yesterday, one today, and two next week at this website. We ask that you please keep your microphone muted throughout the presentation. Also, it would be good if you would put your view in speaker view so you can see who is talking at any given time. You can turn on your video if you would like. And then we also ask that you post your questions in the chat. I will be monitoring the chat as the presentation is going on. And then when the time comes for questions, I will ask people based on the order they've been given to unmute and ask their questions. Or if you prefer, I can read your questions for you. At this time, I will turn over to Mags and Ashish.
Thanks very much, Nicole, for that introduction and for hosting us this afternoon. I presume that you can see my slides. Can you just confirm that you can see my slides?
Yes.
Great, thanks. Okay, so as Nicole said, this is the second in a series of 4 seminars where we're reporting back on some of the experiences of these 2 projects that have been funded through CGHE, the Understanding Student Knowledge and Agency project, and the Graduate Experiences of Employability and Knowledge. And our focus this afternoon is how the graduates from these programs reflect on their knowledge that they gained from their university degrees. Just to start off, just to remind you that this is part of a larger project, and just to acknowledge the hours and hours of work done by the larger project team in the UK. That was Paul Ashwin, Jan MacArthur, Kaylee Rosewell, and Dee Daglish. In South Africa, myself, Renee, and Ashish was the postdoc on the project in South Africa at the time. And in the United States, Jenny Case, Nicole Peterson, who's our chair this afternoon, Ala Abdallah, and Benjamin Goldschneider. And so what Ashish and I are presenting here is based on the work of this larger group. So what are we going to be doing today? I want to connect briefly back to some of the reflections that Jan made on Tuesday with respect to, on Tuesday, Jan was talking about what the each of the people involved in giving of these programs were thinking about, and how they had designed their curricula with specific ends in mind. Where did the students land up? How they're using their knowledge, and what worldview do they hold, and how do they solve problems? And Ashish will do that, all of that middle section. And then I will come back and talk about the overall transformations through engagement with knowledge. But before we do that, in case anybody was not with us on Tuesday, just a reminder that this is a 7-year longitudinal project where we track students in chemistry and chemical engineering programs from their first year through to their 7th year. For some of those that would have been continuing in postgraduate study, for many of them, it was continuing into the world of work. But essentially what we wanted to look at is 2 very closely related programs. Chemistry and chemical engineering have a subset of knowledge that does intersect. And yet these 2 programs are oriented in very different directions. And so what is the impact on the students and how they navigate through that? So I'll begin just talking a little bit about the chemistry departments. Jan picked up that all of the chemistry departments focus very much on giving their students a solid foundation in chemistry. And some of the notable things were, all of them talked about developing problem-solving skills. For the most part, with the exception of one university that had a very small department, that was Erbium, they spoke about the breadth of the offering. And I think one of the notions that's very key to most chemists, and I'm a chemist myself, is this idea of chemistry being the central science. It's sort of links, it is the science that many other sciences need to go through in order to communicate with one another. There were two notable exceptions in that, where Europeum, one of the English universities, focused specifically on analytical chemistry, and Samarium, one of the South African universities, mentioned specifically the beauty of chemistry. This afternoon, we're going to focus just on the English and the South African universities because of the similarity of their degree structures. For various reasons, we've decided not to engage terribly much with the data that came from the institutions in the United States. That's partly because building on work we've done before. So first of all, where are the chemists at year 7? So I went through this and clumped them into clusters. From Erbium, 2 of them have ended up doing PhDs, 3 ended up in quality control type positions. 1 was working in a laboratory as a technician, a couple were teaching, and 1 was working outside of chemistry altogether. Europium, fairly similarly distributed. For sodium, a few more were continued on to further study. And the crucial takeaway from the slide is not the detail of where they all ended up, but here are some of the important things to hold in mind. That 22 out of the 30 have jobs that directly draw on their training. So that would be the first 4 of those columns, from MSc, PhDs, working in quality control, lab tech, and teaching. Teaching, obviously, all of them were teaching in at least one of the aspects of teaching was teaching chemistry. And so all of those, the students who come out in this section are in these first 4 columns, are drawing directly on their content, which is actually pretty good going statistically relative to what one expects from people doing a general Bachelor of Science degree in chemistry. What was notable, I think, was that only one of the South African students, that was the person who ended up in the quality control space, versus 8 of the English students have lab-based jobs. I'm not going to comment on the labor market in South Africa terribly much, but I think it is notable for those teaching in South African programs that we need to think quite carefully about where our students are ending up. And I think what's important here is that it is entirely unsurprising that from all of these programs, we have ended up with students continuing on into further study in chemistry. Just bear in mind that these data are self-selecting. This is a small subset of the students that we began with. So these are sort of broad brush strokes. Please don't take these as being statistically significant in any way, shape, or form, but just noting some of the general patterns that are emerging from the data. Switching to chemical engineering, the chemical engineering departments all had slightly different approaches. Erbium had a strong focus on sustainability. Europium had a focus on strong chemistry. Europium is also the university where in their chemistry training, they focus very much on analytical chemistry. Samarium had a focus on environmental issues, and sodium focus on problem solving in engineering. This is sort of in a slightly more generic kind of a way. So where chemistry had a very clear sort of golden thread, all the chemistry departments were focused on laying a good, strong foundation for the for chemistry and for chemical engineering, there was much more differentiation of this is the kind of engineer that we're trying to produce. And so where did they end up? And I think this is, there are a couple of things to take away from this as well. Here we see that there's a much more sort of scattered view. But the crucial thing, I think, is this, that only 3 of these students are actually working as, 3 of the graduates are actually working as chemical engineers. Some of them have continued in chemical engineering and therefore would be drawing on the undergraduate, the knowledge in the undergraduate degree. But I think what's crucial here is that it's only 11 out of the potential 26 that are drawing on content from their degrees. So this is a far lower number. And the reason for this, of course, unsurprisingly, I think most of us would know that engineers, and chemical engineers in particular, are quite highly sought after in the financial sectors and other spaces. I think what is particularly interesting here, though, is there are a number of students here, having done an engineering degree, are retraining. So there's one student who's begun to do medicine, and another student there's another student who's also retraining. I forget what they're retraining in, but it's just notable here that it's a slightly different picture. The reason that I find this interesting is that many students, when they came into the program, spoke about choosing chemical engineering over chemistry because it had a defined career path. And yet, at the end of the day, very few of them actually pursue that specific career path. That, for the most part, they are well employed. But it's interesting how they come into the program in a particular way. And so now I'm going to hand over to Ashish, who's going to take us through how they've engaged. That's sort of giving you the bigger picture of where they've ended up. So when we talk about how they're engaging with the knowledge, you've got some idea of the spectrum of where they may be now. So let me hand over to Ashish.
Thanks, Max. And then thanks, Nicole, from earlier for hosting us. So as Max noted, how students in chemistry versus chemical engineering across the 4 universities that we are talking about had different sort of levels of engagement that they had with their discipline when they went into the job. And that is quite evident in our data that we are presenting when they talk about knowledge and how they are engaging with the knowledge pieces that they interacted with during their degrees. So I have on the screen here 3 quotes from, can you go back to the earlier one, Max? So I have on the screen here 3 quotes from chemistry graduates who are in the 7th year of their in the 7th year. And the way we are counting this is that the first year is when they went at the university. So this is their 3rd year or 4th year, depending on if they graduated in the 3rd year, after 3rd year, or the 4th year. So this is their 3rd or 4th year doing work or at their workplace. So I have quotes from 3 students, Haley from European, who is working in research lab and developing methods, testing procedures, understanding the chemicals and instruments. And that is all kind of directly linked with chemistry and what she learned in her degree at the university. Similarly, Simon from Sodium is doing a PhD. And now we all know if one does a PhD in a particular discipline, you have to engage with the knowledge that was introduced to you during your undergraduate degree. So Simon is talking about how undergraduate degree gives him the foundational knowledge, which is assumed at the PG level. Now, Damien from Erbium is working in the DNA lab and does chemistry in disguise. So it's not directly chemistry, but there is some bit of chemistry involved. And as Max earlier said, chemistry a lot of times is perceived to be the science that is the bridge between different sciences. So although Damien is working in the DNA lab, there is some chemistry in disguise that he has to work with, where he needs to understand the underlying principles and use lab skills and techniques that he learned in his undergraduate degree. Next slide, Max. So now, in contrast to what students our graduates in chemistry are talking about in terms of how they're engaging with knowledge that they came across in their undergraduate degree, engineering students talk about their knowledge pieces differently, right? So this quote that I have on the screen from Rubia, who graduated from European, and Rubia is talking about sustainability, right? So which is a part of chemical engineering, but not so much as the core body of knowledge as the chemist or chemistry graduates were talking about. So Rubia is working as a sustainability engineer and in the sustainability department. And as she is there, she is talking about how her focus in the job is around sustainability and working toward a net zero goal, right? So she's working for developing options for different types of not net zero goals, and which is a lot of what she did in chemical engineering, but it's more of computing skills that she is using here than the core body of knowledge from chemical engineering. Next slide. Another quote from Nisha, Nisha is actually from Sumerium, so there's a typo there. So Nisha is talking about how she has a background in chemical engineering, but she's also highlighting, which is quite incredible, right? Like when she's working in the industry at the workplace, she's talking about how there's a gap between chemical engineering undergraduate degree, by which she means the knowledge that she encountered or got exposed to through the degree, and the business or corporate or financial environment, right? And that thought or that opinion is a product of the fact that she's working in a job where she does need to do a little bit of financial work or a little bit of business work, right? So she's looking at big systems and processes, but she has to do it at a bird's eye view, thinking of it from a corporate or financial perspective, and then optimize the work that she's doing from the point of view of efficiency. So now we saw sustainability in the earlier quote. We are seeing efficiency of doing work in this quote as it relates to business world. Next quote. And then finally, Leon, who is at Erbium, who is talking about, like just not using a lot of chemical engineering knowledge at all. So as Leon says, I don't necessarily have to every day make use of my degree. So he's not really using any of the knowledge that he gained through his degree. And what he's really just using is the professional skills that he got exposed to through the degree. So he's using teamwork, or probably he's also using communication skills, but it's not the core body of knowledge that he got exposed to during his degree that is being used in his work right now. So now we see how the chemistry versus chemical engineering graduates are talking differently about the knowledge that they are making use of in their workplaces. On the one hand, chemistry graduates are directly using the core body of knowledge into their works or whatever they are doing currently. On the other hand, what chemical engineering graduates are doing is using bits and pieces of the knowledge that they got exposed to. And there is a lot more broader sense of the knowledge that they got exposed to that they are using. So either sustainability or efficiency, but it's not necessarily just the core body of knowledge that they are making use of right now. So that's where the interesting contrast for us lies in terms of how graduates engage with their disciplinary knowledge as they go into the workplace. Next slide. So now this brings us to talk about the view of the world that these graduates hold, right? So what worldview that they have, how do they see the world? And obviously, this is not to say that this happened whether through the exposure to different kinds of activities or courses or knowledge in their undergraduate versus the kind of jobs that they're doing now. This could be a product of one or the other or both. So we are not really too much interested in talking about why they have this kind of worldview, but what we want to look at is what worldview they have at this point of time when we interviewed them. And we will see interesting contrasts in how they are talking about their worldview as they are today or at the time of the interview, right? And this should be looked into with the background or the idea that a lot of people argue that the transformative part of higher education is through immersion into a specific discipline, right? It's not the generic skills that the higher education gives to students, but the transformation or the shift in the worldview happens because one gets immersed in the disciplinary knowledge that they are exposed to during their undergraduate degree. Although, again, as I said earlier, we are not really kind of claiming that all of this happened through their undergraduate degree. A lot of this might have happened because of the certain kinds of jobs that they're doing, but it's just something that is interesting to bring forth before we talk about what the differences in worldview we observed among the graduates. So next slide. So for chemists, they had, when we talked to the chemists across the 4 universities, and these chemists were doing different kinds of jobs, and then Max has earlier talked about, where the majority of chemists or what kinds of jobs majority of chemists were doing versus what kinds of jobs the majority of engineers were doing. But one of the things that we found was in terms of their worldview, most of the chemists talked about the view of the world that was at molecular level, right? So they would talk about what is happening at the atomic level when they look at the world. They will talk about a very fine-grained understanding of what's happening, like what are the individual parts and then how do they interact. So what's happening beneath the surface, right? So if you're seeing something, there's something happening at the atomic and molecular level, and the chemists will talk about that. On the other hand, engineers, when they talked about their own views of the world, they would talk about it from a more efficiency perspective. So they'll talk about how something can be made a bit more efficient, or they will talk about how something is not so sustainable and can be made more sustainable, right? So when they'll see processes and activities happening around them, the first thought that will come to their mind was like, oh, how does it relate to sustainability? Or is this practice sustainable enough? Or they would think about it from a more cost effectiveness point of view, right? Like they'll think about the amount of money that is being involved into doing something and how they can, maybe save a little bit more money. Right. So there was a clear, again, distinction between the views of the world that the graduates from chemistry versus chemical engineers held when we interviewed them. And so next we'll look at some of the quotes from different graduates in chemistry and chemical engineering and try to see how they talk about these different views of the world when we interviewed them. So we have a quote here from Donna, who graduated from IRBM and now is working as a data solutions architect. So she talks about how, as the quote says, right? So I would describe chemistry as the makeup of things at the finest level of grain and detail, down to the very particles that make everything that we know. Right. So again, just thinking about, okay, what's happening beneath the surface? What's happening at the molecular level? She adds on to say, like you can have the exact same ingredients, but if you cook them in different ways, things will interact differently at different temperatures, and you will get different dishes with different taste, right? So again, thinking of it from a very, very molecular point of view, right? How things are structured or put together, or how the molecules interact, or how the atoms interact, and what kind of processes they have gone through, right? So, and that kind of is, again, going back to what we said, right? Like chemists talk about the world at a very, very molecular or fine detailed level. Next slide, Max. Again, Muhammad, who graduated from Samarium, is currently doing a master's in chemistry, and again is talking about, what's happening beneath the surface, like what is it that things are made of at the molecular level, right? So now he's thinking about canned food, right? And again, like this is how he's looking at the world. Like he's going to the supermarket, probably looking at food that's canned and is in shelves, and he's thinking about, okay, what kind of liquid is that food kept in so that it's preserved? What is that liquid made of, right? And that's a question that he starts thinking, or the question that makes him curious when he goes to supermarket, right? So that's again like thinking of the world at a very molecular level beneath the surface of what's visible to the eyes. Next slide. Harry, who graduated from European and is currently working at the National Nuclear Lab, is talking about his view of the world and thinking about, like when he is doing some do-it-yourself activities around the house, he's again thinking about what is it that can cause hazard, right? What is it that can, create something that can lead to potential danger? And this probably comes from his own work in the nuclear lab, where one has to be very careful about how hazards can happen, and has to be extremely, extremely careful about not having something blast, right? So, so again, like this, that there is that view of the world being shaped by the kind of job they're doing, but again, it's not around efficiency or as much as, like thinking about, okay, what is it that can cause hazard, right? So slight shift from what the earlier two quotes said, but again, more or less for us in the same bucket. So for the next, we move on to talking about engineering graduates. So Tanika, who is currently doing, who graduated from Sodium, a South African university, and is currently doing a master's in chemical engineering. And she's talking about, like her view of the world, right? And then she starts with, words like optimizing or efficiency, right? And then she's talking about how, like when you talk to people around you and when you use these words, people don't understand this. Like people don't use these kinds of words on a day-to-day level. But as a chemical engineer, she's thinking about these very subconsciously at all the times. Like she's thinking about how bike works, how heat transfer happens in cooking, right? Like she's thinking about solving problems, what are the advantages and disadvantages of solving problems in a certain way, or how, when heat transfer happens while cooking, or how a bike works, can you make it more efficient, or is it the most efficient or optimized way of doing things, right? So how we are seeing how, although both chemical engineering and chemistry graduates more or less draw from the same body of core knowledge, the way they got exposed to the different curricula in their degrees now are helping them see the world in very different light. Next slide, Max. Now we have Nisha from Samarium, who is working as a junior project engineer. And again, she's talking about, again, thinking of how she can go from one place to another. And we had another quote from Nisha earlier, like where she's talking about, how she can go from one place to another in a most efficient and cost-effective manner, right? And then she goes on to describing, how while building a chemical engineering program, a chemical engineering plant or chemical plant, you have to break things down into different components and then put it together. But again, think about, as the last sentence in this quote says, think about how do we lower the capital cost? How do we lower the operational cost? How do we have fewer safety implications? So again, thinking about it from a very process point of view and optimizing labor, operation, and capital costs. So again, a view of the world that is again centered around very much reducing the costs, improving the efficiency, which was not something that we saw very vividly in our chemistry graduates. The next slide. And finally, Lawrence, who graduated from Erbium and now is working as an energy safety consultant. He's again talking about, how his view of the world is thinking of the processes, how things are happening in different areas around him. And in this case, he's talking more directly around his view of the supply chain shortages in his workplace, right? But again, it's a process that he's trying to think about. It's a process that he's trying to optimize, or at least he's thinking about the shortcomings of those processes, right? So as we see in these quotes, there is obviously a lot of influence of the kinds of jobs that they're doing that shape how they are thinking about the world, because they're talking about their own worldview, also from the perspective of what job they are doing. But this cannot be negated. This fact cannot be negated, that a lot of that also comes from the degree that they were in, right? And then it's very difficult to parse, like, okay, was it really the degree or was it really the job, and how much of a combination of the two their worldview currently is. But as we know that from the intention, so as Max earlier talked about what the intentions of the degree programs are, we know that the chemical engineering programs were more focused on processes and safety and efficiency and things like that, which chemistry programs were not as much focused on. So there's a clear distinction into how graduates are shaped through exposure to that kind of knowledge. So from here, I'll let Max talk about the different problem-solving ideas that graduates have, and as they talk about these problem-solving skills into their workplaces.
Great, thanks, Ashish. So there are just a couple of points I want to draw out as we kind of come to the end of our presentation. One of the things that I found very interesting was looking at how all of them talk about problem solving. And certainly, if we go back to what the chemistry programs claimed, that they had a focus on problem solving, and that certainly comes through in the data. So what's very interesting here is just, this is contrasting engineers and chemists, and they all have this notion of, in order to solve a problem, you need to break it down into small steps. So Tammy from Sodium says, break it down into smaller steps. Tracy says, break down the problem into small achievable tasks. Both of those are engineers. And the chemist Mason from Samarium says, it's the desire to understand and break down complex concepts. What I found interesting, though, is that in just a few of the engineers, you only saw it in the engineers and not in all of the engineers. So this is exemplified with Leon from Erbium. He's talking about problem solving, and he says it's about breaking things down and then building it up into a bigger picture. And that notion of building it up into the bigger picture, Leon wasn't the only engineer to mention this, but it only came through in the engineers. And I think that is, again, we probably don't have enough data to back this up, but I think it's much more associated that molecular understanding is quite reductive, break it down into smaller pieces, whereas that process thinking is then offers the ability to say, well, if I take this part out and replace it with something else and put it back into the bigger picture, what happens? And so it's just kind of an interesting juxtaposition there of how the engineers are talking about problem solving, which I personally just found quite striking. What else have they gained? Well, as somebody who's educated chemists in the past, it's quite nice to hear Damien at Erbium say, of all of the sciences, chemistry is one of the most diverse and interdisciplinary. And certainly many chemists will tell you, do chemistry because it gives you options. And certainly Damien seems to have experienced that. Hayden quite delightfully says his undergraduate degree has given him the tools to pursue education in his own free time without guidance. He's learned how to learn. For me as an educator, that really is a wonderful thing to see. And then Samantha from Sodium says it's the ability to study something abstract, the understanding of the world and the chemistry behind everyday life and things. It's the ability to engage with the world in a new way. So again, what we're seeing there is evidence of something of that, certainly with Hayden and Samantha there, something of the transformational effect of engaging with this particular discipline. Connecting to the intended focus of the curricula, I think that those who are very intentionally creating the curricula, particularly in chemical engineering, would be a little disappointed to see that this doesn't come through all that strongly in the students. So Erbium has an issue on sort of energy and environmental climate change, that kind of stuff. Leanne is one of the few students who mentions that, saying mainly around things like energy issues that are going on, environmental climate change, all of that kind of stuff, noting that has come from her education. And from Samarium, Nevin notices efficiency, sustainability, and problem solving, and importantly, not negatively impacting the environment. given the strong environmental focus of the program in Sumerium, Nevin's really the only one who specifically mentions the environment in his final year interview, which I think it's just, this is not to suggest that the graduates from these programs are not conscious of this, but it is, the distinction between the programs is much less evident when you're talking to the students than I think the people who are designing the programs would like to hope the impact has come. Key takeaways at the end of the day: these degrees are shaping the students' way of being in the world. And there is both overlap and distinction between the chemists and the engineers. And the specific focus, as I said, of the engineering courses is not as evident as the intended curricula would suggest. And then finally, just the kind of the curiosity that I have at the end of the day is talking the persistence of narrative around jobs. So when you talk to the chemists, the chemists who are designing the curriculum, they're very cognizant of the fact that many of their students will not go on to pursue chemistry. And so they talk about much more generic things. And for the engineers, they're very focused on creating engineers. And yet, in this very small sample that we have, it turns out that many more of the people, as I said, it's a self-selecting group, but it's kind of interesting to see how pervasive that narrative is. And the data that we have suggests that it may be time to look a little bit more deeply at that narrative and to see what is actually true in the space. So I'm going to stop sharing there and we can open up for questions. So I'll hand back to you, Nicole.
Thank you, Mags. Thank you, Ashish. We have, wait. It's my video. Yes, we have one question in the chat so far from Christina. Christina, would you like to unmute and ask your question?
Okay, hello, can you hear me?
Yes.
Okay, hi there. Hello, thank you very much for this presentation today. I work at TU Delft, and I'm really interested in just students' perceptions of their education, and especially those who have graduated, because I really feel that has to be part of the curriculum design. I suppose my question was more related to, let me just go back to it so I don't diverge now. Bear with me for a moment. Just bear with me. It was related to, yeah, you know, it seems that we had different types of engineering education, you know, from the interviewees. There were different things mentioned. I suppose by the end of your presentation, I understood that what I've written down is the interesting thing is breaking things down and building them back into a bigger picture. So what I understand from that is the framing and the context are very, very important, right? Students, for them to understand when they receive knowledge, where to plug that in, right? Into their contextual framework. And when they interface with the world afterwards, how they can, you know, use that. But I wonder if in engineering education, there's a way, like it's a question is, do you have any insights, or through this process of exploration, did any insights come to light in terms of how maybe some of the commonalities between students' input, how this insight from students can be used as a springboard for better curriculum design? What can we do as educators to ensure that this process, that their ability to, what was it you also said? The way they see the world, right? Their worldview. How can we make that bridge clear?
Yeah, it's a great question, Christina. And I think, you know, this, in terms of the data that we've got from this project, our goal in this project was not to look at specifically how they were relating to, you know, relating back to a specific curriculum. I think that work would be very interesting to do, but I think that it relates sort of obliquely to other work that I do in terms of kind of knowledge structures and making these things visible to students so that they can actually think about how this piece of work associates with this other piece of work over here and what the connections are between them. And I think that we presume that students are able to make those links because we have those links in our heads. And I'm not sure that that presumption is often justified. So I think there's a lot of work to be done there in terms of how we scaffold things like assessments to make those connections a little bit more explicit, so that the students begin to go, oh, I get thermodynamics is important in this section over here too. It's not just a course. But I think one has to be intentional about that. I don't think that happens accidentally.
Absolutely. I think what I thought while I was listening to you is how to orchestrate the aha phenomenon, right?
Exactly.
You know, which is a bit of a magical moment where the students make those connections, right? And I suppose that's the magic of teaching. It's that you don't only put across information, you create circumstances in which you know are fruitful and fertile for those connections to be made in the student's mind, right? And I suppose you're right, and I thank you for your answer, but I do think that's probably a separate study, is how curriculum design can be sort of improved, especially in the era that we live in, where we are increasingly living in an interconnected world, right? Where, you know, it's about making those links between a rhizome of information, essentially.
Yeah.
Thank you.
Thank you, Christina. Any other questions? We have about 15 minutes, 16 minutes. I guess I'll post one to keep the conversation going. To Mags and Ashish, like, what was the, I don't know, most surprising similarity or difference that you saw? And especially given that we've been talking to these students for 7 years. So are you surprised that a whole lot changed or that nothing changed?
I think for me, kind of just beginning to dive, because, you know, the way that we've been analyzing this data, I'm much more familiar with the undergraduate years than I am with these 3 postgraduate years. And I think what is delightful for me is seeing these students go out into the world, in a sense. The ones who are doing masters and PhDs are much less interesting to me, just because I know those students in a way, because I've taught them. But it's the students who have gone out into the world and how they continue to think about what they've done and what value sense they make of their degrees. So even the students who end up working in an entirely different place, or the student who's retrained, he's now at medical school, is still saying, my undergraduate degree was valuable because it taught me resilience and it taught me, you know, these other things. So I think that there's a really interesting and useful space in this to look at the way in which these students have been shaped. And I think in some way, because they've been a part of this process, you can hear some of them say, oh, I've heard, you know, I remember you asking me this question last year, or I always ask this question, I ask this question slightly differently. I forget what I said last year. So I think it would be interesting to talk to these students about how the experience of being part of this project has shaped their self-understanding. And the way in which they've managed to integrate being a chemist or being an engineer, because I suspect that being part of this project may have been helpful to them in some way.
And I'm just adding on to what Max is saying, right? And then I'm in the same boat as Max is, because I've also not looked at the data post their finishing of the degree as much as I've looked into their the data from their undergraduate days. And one of the things that I find interesting is then is just this connection to, what is it that they are doing today in their workplaces, and how is that skill, and whichever the skill might be, right? Like that skill that they're using in their workplaces is a lot being derived from their undergraduate education, right? So they might be doing quality control, or they might be doing lab work in chemistry, or they might be teaching chemistry or physics somewhere in a school. But how much of that is derived from their undergraduate degree, right? And this is something that came up in one of the quotes that Max talked about, which was a student talking about learning how to learn, right? So there are skills that one needs to learn all the time, like not just in jobs, but also in our everyday lives, right? So figuring out how do we learn some of the things, how do we utilize the resources around us, right? Like, I mean, in today's world, like we have pretty much everyone has, or people who are in the space have internet at their disposal. I don't want to say everyone. So how do we utilize some of these things that are around us to do what we want to do or learn what we want to do, like to get and I think this kind of goes back to the question that Jenny has just posted in the chat, right? So how do we talk to policymakers about the value of higher education, right? Especially when there are financial implications and maybe time-related implications on students' part. Is then, like there are skills that these people get in their undergraduate degrees that help them probably perform better what they're doing at their workplaces, right? Even if they have not learned that skill directly, like maybe they have not learned, I don't know, something like, I don't know how to, like maybe how to write a program using a certain programming language, but maybe they learned something else during their undergraduate degree that was very similar to what they're doing now or learning now, and they can draw from that skill to learn. And then I think that is what is very interesting. And one thing is that, like, I mean, and I have personally always believed that, like, it's always difficult. It's quite difficult to design curricula to meet very, very specific needs of the industry, right? Like, so because I think Amazon probably has a different need in their graduates than L3 Harris has, right? So how do we then design curricula to say, okay, now you're really ready to go work at Amazon, because we don't know if this person is going to go work at Amazon, right? So what is key for us then is to think about, okay, is this person prepared enough to go to work at any of these places and say, okay, I can learn what I need to learn in a few days. Like I do know how to learn because my undergraduate education taught me that. And I do have some of the background to not feel completely lost when someone's using words that are related to my undergraduate degree. So I have the basics and I can build up from there.
Thank you. Jenny, would you like to, I know Ashish alluded to your question, but would you like to unmute and ask your question?
Yeah, thanks very much, Nicole. And if you don't mind, one of the family asking a question. But I'm really struck. I mean, this has been such an extraordinary project that you can be involved in it. But every time I hear anyone speaking on it, I like learn things I didn't know. And I really, this has come out so clearly across your presentation today, but I'm sort of pushing you to crystallize it even more, either Mags or Ashish, if you want to pick up. Because what you're saying so swims against the current discourse around higher education, employability, the purposes of higher education, and STEM education especially. So get a STEM degree and you'll get a job. And it, the assumption is there's quite a close correspondence between those. Everybody knows, well, people assume there's less of a close correspondence in, say, humanities and social science, but and like, how do universities own the space of speaking more powerfully and more sensibly about what we do and what is the value to the public, rather than letting other voices take that over, but just acknowledging it's a constrained time we're in, and the pressures on young people and their families, the anxieties of middle-class people about jobs, You know, if I just give you the microphone now and say, speak to the, let's talk to the Department of Higher Education and Training in South Africa for starters. I mean, I do think it's fascinating what you've shared on where our engineers and chemists landed up. And I think there have also been big changes in the labor market in the last decade or so, definitely in South Africa. So, hey, over to you. What's your pitch?
Okay, so my pitch to DHET, I'm not sure I've got one, but I think in terms of the value of these degrees, I think, and it's not just these degrees, the value of higher education more generally, right, is that mastery of a discipline enables mastery of other disciplines. And I think that's the central thing that higher education is about, that once you know what it is to know appropriately within that discipline, then you can begin to see what it is to interact in another space. So you begin to know, oh, I'm completely ignorant here. I need to go do this micro-credential on that thing. Or actually, I do know quite a bit, and I just need to read a couple of papers, and then I'll be fine. I think that is the value of a higher education degree, rather than the content. And I think, again, part of the issue, I think we in higher education are also guilty, and I'm talking again as a chemist here, because much of the disciplinary-based chemistry research is focused on how do we get this specific, make sure graduates understand this specific concept. They do have to understand the concept, but it's to understand that they understand the concept is the thing that we're actually trying to teach. So I think it's really important, and particularly, and in these days where things like interdisciplinary and transdisciplinarity are becoming the new buzzwords, certainly here in South Africa, it's very dangerous. We need to be very careful about what we're talking about, because we really do, the graduate, somebody who knows a little bit about a lot of stuff is not someone who can pivot between areas. It's someone who knows a little bit about a lot of stuff. So I think it's a great question, Jenny, and I think there's food for thought here. And yeah, I'll stop talking now.
Thank you, Megs. We have time for maybe one or two more questions. Any other questions or comments? It doesn't have to be a question. So I'm curious about, I think Ashish mentioned this in his response. I'm curious about how, there's so much research, at least in the US, I think a lot of people talk about this gap that happens between school and work. And we know industries have to train new employees, right? We don't expect students to walk out and walk in and just be ready to go. And there are certain projects, I would say, funded here that takes into consideration practitioners and what they hope that educational programs will provide their graduates with. Your thoughts. There's also a question in here from Brian. So your thoughts about industry being the driving force for educational curricular, and then we'll take Brian's question.
Well, so I find it interesting, right? Like, I mean, I think employability is just one of the many aspects of higher education, right? It's not, and that is probably why, if you look at what the training modules in a particular workplace looks like, and a module at a university, they are different. right? And I've never been through a training module at a workplace, but I'm guessing that the training modules at a workplace are more procedural than conceptual, right? And I think that's where the difference lies. And then that's where we have to be a little bit careful, like people who are at the policy level or administration level, like making decisions about, okay, what inputs are to be taken from the industry. We have to be careful about, okay, sure, if the industry is saying students should learn this more, but if that requires a little bit of reduction in the conceptual backing of the discipline that students are exposed to during higher education, we need to ask that question, is it something that we want to do, right? And going back to what Max said, right? Like if mastery in one discipline is a pathway to mastery in another, then do we have the bandwidth, or should we have or can we really reduce the possibility of students gaining mastery in that one discipline? And sure, in the short term, it might be more challenging for industry to kind of say, oh, but your graduates don't come in with knowledge in, I don't know, something in chemistry or chemical engineering, right? How distillation columns are made. But maybe in the long run, that will be more useful, because even within same job, like people will do different projects, right? Their projects will shift, or they will shift jobs. The graduates will shift jobs, right? So how much should we just worry about like that first job that industry is looking at, right? Because I don't think the industry is saying like, oh, we worked with graduates 10 years down the line, and then we saw that, oh, this was missing based on their undergraduate degree, right? Nobody's really saying that. So that's the like that's where I think like there should be a little bit more thought around that.
Thank you. Brian, do you want to raise your question? I know Max already answered, but we do have maybe 2 more minutes.
Yeah, I mean, my question was, to what extent does the external accreditation of, for example, this engineering degree is recognized in the Washington Accord, or that chemistry program is accredited by the Royal Society of Chemistry. To what extent does that influence the value proposition for the students, or the sort of drive curricular development by the academic staff, or are those just, if you like, epiphenomenal manifestations of a disciplinary culture that's driving within the institutions already? But I take Mag's point that these may not have been addressed directly in the study, and I declare an interest here. I work for a quality assurance agency.
Right. So all of the engineering degrees were all of those countries and all of the programs would fall under the Washington Accord, but the diversity of mode of expression was huge. For the 2 US institutions, they were both accredited by the ACS, and the 2 English universities both accredited by the RAC, but we don't have a similar kind of accreditation. We have a national accreditation body for all degrees in South Africa. So within the national context, there wasn't differentiation between the institutions on those grounds. And so asking that kind of question, then people are, to ask that across nations didn't really make sense. So it wasn't something that we explored in this project at all. But it is a good question.
Thank you. Thanks, Megs, and thanks everyone for attending. Just a reminder that next Tuesday, we will have another in the series talking about professional expectations and personal motivations, science and engineering graduates' reflection on their role in society. You can please register for that conference or for that webinar using the link in the chat, or finding it on the researchcg.org website. Also, a recording of this session will be posted if you want to go back to look over some of the things Mags and Ashish talked about. Otherwise, thank you for joining us today, and we hope to see you next Tuesday.